So welcome back, students. Let us come back and do the next question. Till now I have done 3 sets of questions, right? So when we come to this question, let's read this and then gradually solve. Hope you would have seen all the earlier videos, all the 4 videos. So basically, students, just important thing, if you are all not watching the videos, it is meaningless for me to upload. So you have to be very fast because days are very less for us, isn't it? Yes. So all the best for your NEET examination. Let's start off. So here in this particular question, they've given us an acid solution of 0.05 molar has a pH of 5. Okay. The degree of ionization of acid is what? Basically, we have to find out, or let us see what is given to us in the exam. First, let us note it and just see. Now, pH is given. How much is given? 5. Okay. I need to find one more thing. An acid solution of 0.05. Right. 0.005. The concentration part given to us is concentration is 0.005 molar. And what should I find out? I have to find out alpha. That is your degree of ionization. Alpha is degree of ionization, isn't it? Right. So basically, when pH is given to us, let us write the formula. This is the easiest way to do. Basically, acid, that is your H plus concentration. What is H plus concentration? It is equal to 10 raised to the power of negative pH. That is what we studied, isn't it? The negative pH, or the 10 the base 10, the negative logarithm, that is equal to your acid concentration. How much is pH given to us? pH given to us, now take as 10 raised to the power of minus 5. This is the thing, correct? Yes. So now what is alpha formula, or degree of ionization formula? A degree of ionization is the concentration of the acid by given concentration. How much is the concentration of acid? 10 raised to the power of minus 5. What is the concentration now? Given as 0.005. 0.005. When I cancel this, I get an answer of 0.2 in 10 raised to the power of minus 2. So this is the answer. Simplest way, isn't it? So remember, whenever this is given to you, concentration is given to you and the pH also is given to you, the easiest procedure is this. So the answer is 0.2 in 10 raised to the power of minus 2. So let me take the correct answer. Let us come back and do the next question. Now let's come back and read this question, students. Let's see what have they asked. They've given this is an organic based question. Let's see, which of the following compound does not have any geometrical isomerism? Okay, so first important thing, whenever a geometrical isomerism question is given to you, what should you remember? So geometrical isomerism, basically there are cis and trans. And next important thing is, if a particular compound has to show geometrical isomerism, it should have the group should be on different carbon atoms, because when you rotate it, cis and trans isomerism. Okay, so when you rotate, there should be movement, or there should be change of that particular position of that particular atom, right? In this particular question, they said which does not have geometrical isomerism. I said for geometrical isomerism, the particular atom should be present on different carbons. Here it is different carbons, so this will show. Now here again it is on different carbons, so this will also show. Here also the chlorine is on different carbon atoms, this also will show. Now in the last case, here chlorine is present in the same carbon. Just see now, even if you rotate also, there is no change in the structure, or there is no isomer formed from the structure. So option D, right? The option D is a correct answer, which does not have any geometrical isomerism. Why? Since the atoms or similar atoms are present on same carbon atom. This is what you have to remember, right, students? Right. So this is the easiest way. So the option D is this one. Option D is this is the compound which does not have, or which will not show any geometrical isomerism. Right. Now let's come back and do one more question. Let me move my book clearly. I think this is clear enough for you all. Just see. Let me adjust my lens. Yeah. So now let us read the question. What did they give us? Calculate the concentration of a solution obtained by mixing 300 grams of 25% weight solution ammonium chloride and 150 grams. This is off here. Okay, I have to calculate what? I have to calculate the concentration of the solution. Okay, so and obtained. So when by mixing 300 grams of 25% by weight solution ammonium chloride and 150 grams of 40% by weight solution of ammonium chloride. So they are given two things. One, they have given weight of solution 1 and they have given weight of solution 2. Right, what should I find out? I have to find out concentration of the solution, right? They've given me 4 options. Let us start off. So when such question is given to you, basically let's make it easier and solve it. First, what did they give us? Weight of solution 1 and 2. First of all, I have to find the weight of solution 1 and 2. I'll tell you what. Weight of solution 1 and weight of solution 2. How much? What is weight of solution 1? It is 300 grams. What is weight of solution 2? 150 grams. So total of 450 grams is the weight. Now let's take using that individual weights, let us calculate the weight of solution 1 and solution 2. So now let us write weight of solution or weight of ammonium chloride in solution 1. Second one, weight of ammonium chloride in solution 2. Right? So in the first one, how much is given? It is said 300 grams of 25%. That means 300 into 25 by 100. In the second case, how much they say? 150 of 40%. 150 of 40 by 100. So when I solve this, how much do I get? I get, okay, this comes to 75 grams. When I take this, okay, this comes to 60 grams. Now, right now this is weight of the solution. Individually we have calculated according to the percentage. Now total weight of ammonium chloride, because this is solution part, this is ammonium chloride, so let us write total. Therefore total weight of ammonium chloride, how much do we get? 75 grams plus 60 grams. How much this is coming to? 135 grams. Now percentage by weight I have to calculate now, because they have given the answer is the percentage by weight. So what will I do now? Therefore percentage by weight of mixed solution. Percentage by weight of mixed solution. How much did I get? Today I got 135 grams, isn't it? So now 135 by the total solution, that is 135 by 450 into 100, percentage by weight. When I cancel this, I get 30% by weight. So this is a correct option. Actually, what did we do? We have taken individually. We have taken weight of the solution together. Then I have taken individually ammonium chloride, because they have given 300 grams per 25% of 25%, then 150 grams of 40%. I have calculated individually both of them. After that, what did you do? I have taken the total weight of ammonium chloride, done, but I have to find out percentage by weight of mixed solution, because ammonium chloride in this mixed solution I have to find out. They've given here, calculate the concentration of the solution obtained by mixing. So for the mixed solution, whatever weight I have got here, I have taken the total weight and calculated. Right, let me come back and do the next question. Now this is again grade 11th, grade 12th also you have Habers process, grade 11th also you have. Let's see, what do they give us? In the manufacture of ammonia by Habers process, that is they've given nitrogen and hydrogen here, Habers process reaction, that is basically Habers process, we prepare ammonia, isn't it? Right, so in Habers process, what did they say? They said nitrogen combines with hydrogen, they've given a balanced reaction, and we very well know in Habers process it is a reversible reaction, and the product which we are going to prepare is ammonia, right? And they've given 92.3 kilojoules of energy was released. Done. Which of the following conditions is unfavorable? Now this is important. Unfavorable. Basically, whenever we speak about Habers process, what things should you remember? Remember these points. For Habers process, the reaction is reversible. That is the first important thing. And conditions, what do we do? They are deduced using Le-Chatelier's principle. I think this Le-Chatelier's principle, hope the concept is clear. So we are going to deduce, means the conditions are dependent, or basically according to Le-Chatelier's principle only, we deduce the conditions and speak what happens to get the maximum yield, low temperature or high pressure, like that. Basically in Habers process, the temperature which we require is 450 degrees centigrade. How much would be the pressure? The pressure which we require is 200 atmospheres. 200 atmospheres, right? Now, so according to Le-Chatelier's principle, if I have to get more of the product, the temperature should be low. Most important thing, remember this. What in according to Le-Chatelier's principle, to obtain more product, what is important? Low temperature is important. So because of this, what it proceeds to the forward direction. Done? Yes. So I have to remember these conditions and think about the option. Now they said which of the low temperature is important as well. With this low temperature only the means the reaction proceeds forward direction, otherwise it goes back reverse direction. Now let's see which of the following condition is unfavorable. Now increasing the temperature is one, this one, increasing the pressure, reducing the temperature, removing ammonia as it is formed. So now see here, I said low temperature is important, but what is the first option? Increasing the temperature. If you increase the temperature, what happens? I said the product means it goes in the reverse order. That's why the unfavorable condition in Haber's process is option A. So if temperature is increased, as I told you, the yield of ammonia will become less. Right? Done. So let's come back and see one more question. Let me move my book further. Yes, let's see this. So in this question, what is given? Let's read. Molecular weight of an organic acid is given by equivalent weight into basicity. Okay, equivalent weight by basicity. Done. Basicity by equivalent weight and equivalent weight into valency. So basically here they've given molecular weight of organic acid. Correct? This is where is important because it varies for the base, it varies for the metal, everything, isn't it? Right. So molecular weight of organic acid, simple, direct, it is a direct formula. Remember, molar mass or molecular weight, molar mass of an acid is equal to equivalent weight into basicity. This is a direct formula which you can use it. So direct, as I told you, I have given the answer. Let us come back and mark the first option directly. There is no twist in the question. So molar mass of an acid, a direct question. So I have marked that and I have used this. Right, students? Right. Now let's come back and see next question. Let me turn the page I have. Right. When I turn the page, I have one question here. It's the easiest question again. I have to tell you. What do they give me? What is the structural formula of fumaric acid? Okay. They have given structural formula of this one, fumaric acid. They have given 4 options. So basically this is also a direct question. Fumaric acid, the form or the structure or the formula of fumaric acid is this. Both the hydrogens on opposite side and COOH in opposite sides. Right? They are trans isomers, means it's a trans product basically. So fumaric acid is HHCOH, means trans. Why did I say? Because they are present in the 2 opposite sides. So the structural formula of fumaric acid is T. Right, students? Done. Let's come back and do one more next question. So here, what did they give me? The bond angle of COC, okay, the bond angle in COC, they have given one structure that is of methoxymethane. So what is the bond angle of this, they said. So basically whenever you see the bond angle, or this is what methoxymethane and dimethyl ether, we very well know, according to, we calculate this, means we have studied this bond angle concept in which one? In Vesper theory. According to Vesper theory, the bond angle of methoxymethane should be, because this is tetrahedral in shape, it should be 109.5. Right? So here in tetrahedral structure, what will happen? 4 electron pair will be distributed. In a tetrahedral manner, 4 electron pairs will be distributed. As soon as you see this, directly you will see the structure and you will mark it as 109. Right? Because 4 electron pairs are distributed, and you know why do they distribute? That to reduce that electron, means to minimize pair repulsion in between the molecules, to reduce the intermolecular pair, or in between, to reduce the repulsion between the carbon atoms. They align themselves in this 100, means giving a tetrahedral structure 109.5. But according to Vesper, it is 109. But remember, here this is an exceptional case. Here, according to electron diffraction studies, according to electron diffraction studies, the bond angle was observed to be very close to 112. As of now, was observed to be 112, means basically there's no 112, it's almost 111.7. So remember students, methoxymethane specific case according to electron diffraction. According to Vesper, it would be, as I told you, tetrahedral arrangement. tetrahedral 109, but this is wrong. Here 111.7 is the correct answer. So according to electron diffraction studies, so 109 is for tetrahedral, 180 is for linear, isn't it, like that? So here methoxymethane, the correct answer is 111.7. so don't get confused, students, right? So now let's come back and do the next question. Let me turn my page. Okay, yeah, I have written the questions, right? So let's read this question. What did they give me? In a closed vessel or the closed flask of 5 liters, 1 gram of hydrogen is heated. Okay, there's a closed flask system, so 5 liters capacity. 1 gram of hydrogen is heated from 300 to 600 Kelvin. Which statement is not correct? Okay, they've given pressure of the gas increases, rate of the collision increases, number of moles of gas increases, the energy of gaseous molecules increases. So what option is not correct, they said, right? So the pressure along with number of moles of the gas, it remains the same. Why? Because it is a closed flask, isn't it? In a closed flask, remember, the pressure of and along with the number of moles, there is nothing which is not getting isolated, means there is no distribution. It's closed inside that container only. So that container is how much capacity? 5 liter. How much is there? 1 gram of hydrogen. It is heated from 300 to Kelvin. Everything is happening inside that only. So what option? We said the number of moles of the gas increases, the rate of collision increases, pressure of the gas increases, the energy of the gas molecules increases. See here, pressure of the gas, pressure is inside the same. The rate of collision increases, correct. But does number of mole of gas increases? No, isn't it? Because it is present inside the closed container. So this is the correct option. Number of moles remains the same. Right. Let's come back and see the next question. Right. So here, what do they give me? If two compounds have the same empirical formula but different molecular formula, they must have what? Okay, two compounds have the same empirical formula but different molecular formula. They have given option: different percentage composition, different molecular weight, same viscosity, same vapor density. So if compounds have same empirical formula but different molecular formula, so if molecular formula is different, what will happen? Molecular weight also will be different, isn't it? Yes, right, students? Once again, if molecular formula is different, the number of atoms, means carbon may increase, hydrogen may increase, oxygen may be there. So if molecular formula is different, then molecular weight also will be different. Option B is the correct answer. So hope this is clear, students. Right, let me come back and do some more questions. So welcome back to the next session. I think you've followed the last 5 videos, students. Let's come back and see what are we going to solve. Here in this particular question, this is an organic based question. Let's read this. Which of the following compounds containing carbonyl group will have colored crystalline or will give colored crystalline compound? So remember, which of the following compounds containing carbonyl group? So here they've given one compound. What is this compound? This basically this is 2,4-DNP, isn't it? This is hydrazine at second position and the first position and the fourth position. 1, 2, 3, 4 means if you start like this, okay, this 2,4-DNP second position, yeah, second and the fourth position you have nitro group. So basically this is 2,4-DNP, 2,4-dinitrophenylhydrazine. Now they said this compound is going to give, means among all these carbonyl compounds, which compound will react with this 2,4-DNP and give a colored crystalline compound? So remember, first important hint in this. What is a hint? Only aldehydes and ketones will react with 2,4-DNP. Correct, no? Yes, you have to remember this. So only aldehyde group and ketone group will react with 2,4-DNP. What do they give after combining or after reacting? They are going to produce characteristic red or orange colored solution, red or orange colored solution, right? So this you have to remember. So aldehydes and ketones we said. Now let's see which one is aldehyde or ketone here. So basically here this is acyl group. No, this is which one? It is a ketonic group. Okay, ketonic group I can consider. Here this is an ester, not. Here it is an amine, means CH3CO in H2, correct? So an amine group is present in that. And important thing we have to remember is, I said only aldehydes and ketones are going to combine with this, correct? And so we can rule out that compound also which has an amine group. Yeah, so basically what do we call this? What is the name of this compound? CH3CO in NH2. This is acetamide, isn't it? So this is acetamide, this is an ester, this is an acyl group. So which is the correct option? The correct option is B. Correct, students? Yes. So hope this is clear. Let's come back and do one more. Next question. Let me take this question. Hope this is clear. The most organized. Okay, now we have come to solid state chapter, right? So we have done earlier organic chemistry. Now come to solid state chapter. Let's read. The most organized crystal system is. What is the most organized crystal system? They are asking. They've given orthorhombic, cubic, monoclinic and hexagonal. Basically, Bravais lattices, you need to remember the parameters and go, students. Otherwise, such questions you can't answer. Basically, if I have to see, let me write the parameters for all. When I have to see the orthorhombic structure, okay, orthorhombic. In orthorhombic, what is the criteria? A is not equal to B is not equal to C. Here alpha is equal to beta is equal to gamma is equal to 90 degrees. So is it an organized system? No, isn't it? Because all are not equal. All H lengths are not equal. Now when I have to go to the next one, cubic. Here all the edge lengths are equal. The angle between them also is equal to 90 degrees. Perfect, isn't it? It is perfect organized. Let us write for monoclinic. So when I take monoclinic Bravais lattices, here A is not equal to B, which is not equal to C. Again, it is not organized. Alpha is equal to gamma, which is 90 degrees. Now beta is again 120 degree. Is it organized? Not organized. When I take to the next one, last one, hexagonal structure. So in hexagonal structure, if I have to take what is this one? A is equal to B, but B is not equal to C. Alpha is equal to beta, which is 90 degrees, but gamma is 120 degrees. So this is also not organized. They are not equal. So the only system which is, or the most organized crystal system is cubic according to the parameters. Both are equal, isn't it? Yes. So take this question, students. Now, as I told you, please study the Bravais lattice parameters for all the 7 crystal systems which combine together to form 14 Bravais lattices. Now let's come back into one more question. Let me turn the page. Right. Now, what did they give me? Again an organic question. Propene on reaction with hypochlorous acid gives. So basically propene on reaction. So this is basically whenever you take alkenes, we'll be talking about Markovnikov's and anti-Markovnikov's addition, isn't it? The concept of this. So propene on reaction with hypochlorous acid. So basically let us write reaction. Propene. Propene is 3 carbon atom. So propene CH2. CH3H. This is propene, correct? Yes, 3 carbon. Now hypochlorous acid is what? HOCl. Done? Right. So when alkene is added, there is a cleavage of the bond. There is also a cleavage of the bond, right? So minus. Okay, let us take this OH. This is a minus and this is plus. So the negative addendum. Okay, I should not take this as plus. Okay, let me be careful. Let's see this according to Markovnikov addition. Now let me see this. Now this is Markovnikov addition. It goes according to Markovnikov addition or Markovnikov rule. What is Markovnikov rule? Hope you would have it's clear for you all. You would have studied in grade 11th. I think you would have not forgotten that, because whenever you're studying a concept, right, students, when if the rule, or when I say Markovnikov rule, or this one, if you don't remember, it's very difficult. I'll once again take it, just see. The addition means when I take, you have an unsymmetrical propene or unsymmetrical alkene here. So when you have unsymmetrical alkene, what happens? The negative addendum means the rule states that whenever there is an unsymmetrical alkene like this, the negative addendum goes and adds to the carbon. Where does it go and add? The negative addendum adds to the carbon. Let's see. As I told you, the negative addendum goes and adds to the carbon having less number of hydrogens. So this is the negative addendum. It goes to the carbon having less number. Here 3 hydrogens, here 2 hydrogens, here 1 hydrogen. So what does it have? Break C H OH single bond CH2Cl. This is attached to carbon, CH2Cl. Then what is the name of this compound? The name of this compound is ethylene chlorohydrin. This is ethylene chlorohydrin, right? So remember, addition of HOCl follows Markovnikov addition, and the product formed is ethylene chlorohydrin. So this is the compound, isn't it? This is the compound. Right, students? Right. So hope whenever I say, or whenever you're learning rules, Markovnikov rule, Saitsev rule, anti-Markovnikov rule, you have to be very, very careful, because you should not forget the particular rule, because suddenly they may give you a compound and you should be able to know which one, whether it undergoes Markovnikov addition or anti-Markovnikov addition. Let's come back and do the next question.